Hello and welcome to PA Academy. And so far we've been looking at sets, and this is a part 3 of the video series under sets. So if you missed the previous part of this video, you'll find a link to it in the description below. And if you are yet to subscribe to PA Academy, kindly click on the subscribe button and the little bell icon beside the subscribe button so that you get notified when we release any video. So now in this part 3, we are going to be looking at the types of sets. So right there, I have four type of set that we are going to be looking at. The first one is a null or empty set, the null or empty set. The second one is the singleton set. The third one is the universal set, and then the fourth one is the power set. So the first one is what is a null or empty set. That means what it said. This is a set without any elements. So when you have a set and there's no element, we call that an empty set or a null set. Null set. So he said it is denoted with the symbol, just the bracket, the curly bracket, or this symbol. Let me write it out. So when you have an empty set, let's say a set A. If set A is an empty set, we just have it as this. Let me write it again. So we'll just write it as, okay, if set A is empty, we just have it as there is no element inside. So that means it is an empty set. Or we can also represent it as with this symbol. So just 0 and then you cross over it. So we say forward slash over it, yeah. So that is what empty set is, set without or without any elements. So I said here that note that when you have a set and you have 0 inside, he said it is not a null set because 0 is also an element. What does it mean? So if you have a set like this, let's say we have a set A. Now if it's an empty set, it would be like this. I'm talking about this now. I'm talking about this. So if it's set A is an empty set, we'll just have it like this. There's nothing inside. But once you have, if there's 0 here, it's not an empty set. It's no longer an empty set because 0 itself is an element. 0 itself is an element. So there are just two ways of representing an empty set. Is either you have it, let's say if it's using the set A, is either you have it like this, which is an empty set and there's nothing inside, or you can just have it like, just have a 0 and a forward slash over it. So these are the two ways of representing what this and this are the two ways of representing an empty or a null set. So the second one we are going to be looking, the second type of set is the what is the singleton set. So for singleton set, this is a set with only one member or element. So this one is also straightforward. So when you have a set with just one element, then it is called a singleton set. Look at this example. We just have one element inside the set, that is 0. Here also one element A. A is the only element here, 1 is the only element. So once you just see one element or one member of the set, then such a set is called a singleton set. Singleton set. So the third one is the universal set. So this is very common. So I want you to understand this very well. It said this is a set which have all the elements of the subset. In the previous part of this video, I've talked about what a subset is. So if you missed that, you'll find a link in the description of this video. So universal set said this is a set which have all the elements of the subset. It said denoted with this symbol or E. So this is a symbol for what? For universal sets. It's something like this. So just like a U. So that's how the universal set, that's a symbol. So this is example. For example, if you have a universal set, this is the symbol for universal set. Like it, and then you have all these elements. Note when in set, if you have the way I've written it is 1, 2, 3, 4, then I have dash 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 and 10. So what it means is I just follow the progression 1, 2, 3, 4. So what that means there is 5, 6, 7, 8, 9, and then 10. So that means this is just telling us that there are elements in between. So if the elements are so much and maybe they're due to space and you don't want to write it out, you can just leave this space and then put the last value. So the universal set is just 1 to 10. 1, 2, 3, 4. So there's 5, 6, 7, 8, and 9. So this is the universal set. And then this A and B are subsets. Why are they subsets? Because all these elements 2, 4, 6 are present in the universal set. 3, 5, 7, and 9 are also present in the universal set. So that means the universal set is a what? Let's look at definition again. This is a set which have all the elements of the subset. So you can see that this is a subset. All the elements are what are present in the universal set. So that makes it a what? A universal set. I believe this is clear enough like this. So if you have all the elements in the subset, so even the subset might be more than this, might be more than 2. We can have another set C, another set D. As long as all the elements in these 4 subsets are present in the universal set, then you can say call this what? A universal set. So the fourth one we are also going to be looking at is what? Is power set. He said, for power set, this is the total number of possible subsets that can be derived from a set. So it is denoted by X, by S. So when we talk about power set, okay. So let's say, for example, you have a set A. I don't know why I keep using set A, but it could be anything. It could be set A, set B, set whatever. So let's say we have a set A and we have all these elements. We have A, B, and C. So the total number of possible subsets that we can derive from these elements is what we call what? The power set. We are going to look at more examples as we go. He said the total number of subsets can be determined using the formula 2 raised to power S, where S is the total number of elements in the set. So let me use this example to explain it. Now, if you have this set A, B, C, and you are asked to look for the power set of this set, so what you are going to do is this. We've been given the formula. I said the total number of subsets can be determined using the formula, using this formula 2 raised to power S. So 2 raised to power S is 2 raised to power 3. Don't forget the S, where S is the total number of elements in the set. How many elements do we have here? We have 1, 2, and 3. So there are 3 elements. So that will be 2 raised to power 3. And that's 8. So I said that means we'll have 8 subsets. So for this example now, if you are asked to look for the power set of this set A, the first thing you are going to do is what? You apply the formula, which is 2 raised to power S. And the S is the total number of elements we have in that set. Right here we have 3 elements, just 3, A, B, and C. There's 3. So you just say 2 raised to power 3, that's 8. So that means you can get 8 different sets from this set. So that's what we mean by power set. So that means we'll have 8 sets, and these are the 8 sets: A, B, C, which is the main set itself. We can also have A, B, A, C, B, C, A, B, C. Each of the elements also can represent a set. And then we also have an empty set. Don't forget. So we can also have an empty set from the set itself. So that is what we mean by what? By power set. So when you talk about, you are asked to look for the power set of a particular set, just say 2 raised to power the total number of elements that you have in that set, and that will give you how many subsets you can derive from the set. So this is example 2 now. We say A is equals to A, B, C, D. So right here we have four elements. So given that we have 4 elements, that will be 2 raised to power 4. And 2 raised to power 4 is 16. So that means what? We'll have 16 subsets from this particular set. So the power set for it is 16. The power set for this particular set with 4 elements is 16. And you are going to get 16 subsets for this. So that is it for this particular video, this part 3 on under types of sets. Now for this part 2, before we round up, so you can just try, since we know that it's 16, that the total subset that we can derive is 16. So try and see if you can get all the 16 subsets that you can derive from this. And don't forget your empty set. You also get your empty set from it. So let me know if you're able to get all the 16 subsets, and let me know in the comment section below. And then we're also going to continue this video in the part 4, where we are going to be looking at Venn diagram. We are going to be looking at union and intersection of the set. So with that, I'll see you in the part 4 of this video. Please don't forget to subscribe to this channel, PA Academy. Don't forget to give this video a thumbs up if you like the tutorial so far. And don't forget to also click on the share button. Don't forget to share this video with your friends, your colleagues, and across the social media platform. Bye for now.